You are made of stardust. And as cheesy and poetic that might sound, it's actually the truth. It's science. The iron in your blood, carrying the oxygen throughout your body, was forged in the heart of massive stars and scattered across the universe in colossal explosions. So technically, every time your heart beats, it's powered up by the remains of jet stars.
Or at least sort as if you're not iron deficient as I am.
But let's zoom out a little bit. Why is this iron such a big deal in the first place? And how did massive exploding stars, supernovae, turn out to be the factory line for the thing flowing throughout our veins right now? Stars are born in clouds of gas and dust called nebulae. Gravity pulls together these clouds until it clumps it into a denser ball. The more gas a star gobbles up at its birth, the bigger it becomes. Small stars form when they don't collect as much gas. They're like a campfire. They're warm, but modest. Massive stars form when gravity pulled an enormous amount of gas together. These are like raging bonfires. They burn hotter and faster. That's why we have different types of stars. There are some stars that can burn for billions of years, like our sun, a medium-sized yellow star. While others live fast, burn bright, and explode young. So let's do a cooking/baking analogy right now. Small stars are like easy bake ovens. They can handle some simple recipes, right? They can bake hydrogen into helium and sometimes helium into carbon, but that's it. Massive stars, these are the cosmic steel mills. They stack up heavier elements like layers of an onion. We have hydrogen on the outside at the very edge. Then comes helium, carbon, oxygen, silicon, and so on until we reach iron at the very core. Stars shine because of fusion, smashing small atomic nuclei together to make bigger ones. For example, two hydrogens to fuse together to form helium. This process releases a lot of energy. This is the light and heat you feel and see from the stars. Up until iron fusing lighter elements together release energy. And lighter elements fuse together because they're unstable. They are single, they are sad, depressed, and their goal is to find a partner and be in a stable, great relationship. Their goal is to be stable. So the combined nucleus of two unstable elements create a new, more stable element. So the extra stable bond is shown by the release of energy, which is what powers the star's glow. But iron is different. Iron 56 has one of the most stable nuclei in the whole universe. If you try to fuse it to form something heavier, it will not just snap into place and release energy. On the contrary, you would have to put in energy to force it. So in order to understand this, I would give you an analogy. Imagine you've been running a lemonade stand. Each cup of lemonade you sell makes you money. This is what hydrogen into helium, helium into carbon, carbon into oxygen, oxygen into silicon, and so on. So it's profit. But then you hit iron, and selling lemonade cups suddenly costs you money instead of earning it. So the stand can't stay open anymore. That's why once a star starts to develop an iron core, it's game over. There is no more profit. There is no more fusion. The gravity takes over. The core collapses and the star explodes. That explosion blasts iron and heavier elements like gold and uranium out into the galaxy. It's like confetti at the most violent party in the universe. But now you might ask, why are there heavier elements blasted if the heaviest element in a star is iron? Well, here's where things get wild. When the core collapses, temperatures shoot up at billions of degrees. The explosion unleashes a flood of neutrons and energy. And in this chaos, atomic nuclei get smashed together so violently. This process is called the RN process, rapid neutron capture. And that's when you suddenly get heavier elements than iron, such as gold, uranium, platinum, etc. Over billions of degrees, this star debris drifted. It clumped into clouds, formed new stars, new planets, and eventually Earth. Iron became concentrated into the planet's core and crust, but it also entered the chemistry of life. In biology, iron's unique atomic structure makes it especially useful. Each iron atom can reversibly bind to oxygen. Evolution took advantage of this property and included it into hemoglobin, the protein in the red blood cells that is responsible for carrying the oxygen throughout your body. So the very process that allows you to breathe and stay alive is powered by the iron atoms, which were originally synthesized in supernova explosions that occurred long before Earth has even existed. So every beat of your heart is quite literally the recycling of stellar material.